Hey kiddos, what's up? It's good to see you. I'm sorry I haven't seen you in a couple of days. I was really just trying to get your tests graded yesterday and get those fixed and ironed out. I ironed out all of you that missed question 23 when it didn't have an answer. And the last question you guys missed on lithosphere, which is really disappointing because we went over it, but I don't know, it threw you off, so maybe there'll be a curve. We'll see what happens. All right. But with that being said, that means we start a new chapter. Okay, so now here we've got a couple of weeks left. There's definitely been some changes. I haven't been updated of those changes yet. I don't think there's any finals. I'm not sure, some news coming with attendance or something, but I'll keep you guys updated on that as soon as I find it out. Okay, but with that being said, so here's how I want to work out this last month since we don't have a final. Okay, now instead of doing a whole month of rocks and minerals, I would really like to do the best lessons from here to the end. Okay, so I'm going to do minerals today. We'll finish minerals on Friday because you're going to have a project due, and that's going to be your mineral kind of test, sort of. Okay, so please make sure that your project is good. If it's not good, I will grade you accordingly. But I'm going to go over the project in a few minutes. That's going to be a separate video. Okay, but let's get into minerals because I only have 15 minutes and I've already done this like 6 times. Okay, so, all right, so we're going to talk about minerals. So your student targets. Basically, you need to know the 7 things that basically the 7 properties of a mineral. You need to know the 5 things that define a mineral. Okay, that's like how we know it's a mineral. All right. And then we're going to talk about 2 main groups, silicates and non-silicates. We're going to talk about their structures and things like that. Okay? All right. Now, mineral uses. There are minerals around you everywhere. I know when people hear minerals, most of us think emeralds, rubies, diamonds, jewels, things like that. But minerals are in everything. They're in construction. They're in all the things that you use around you. If you're really, really curious, you can click on the link and you can see 40 common minerals and their uses. You can watch the video that will also tell you a lot of minerals that are around you, but remember I only have 15 minutes and the video is like 4 minutes long, 4 or 5 minutes long, and so I didn't really want to watch that right now. So please, if you want to see some cool stuff, I wouldn't have attached it if it wasn't a cool video. Okay? All right, the 5 things that define a mineral. So like if you're looking at a pebble somewhere, on a beach somewhere. All right? So the first things first, it has to be natural. It's naturally occurring. Okay? So like they crystallize from magma and they occur naturally. Like they're not, made in a lab, they're not, anything like that, completely natural. Second, they're solid. Always solid. Never liquid. Never squishy, never anything like that. They may break apart and be really soft, but still a solid. All right. Generally considered inorganic, which means they don't have carbon. All right. Definite chemical composition. Now, no matter what, they're always going to be, have the same chemical composition of anything. Just like elements on the periodic table. And a lot of elements on the periodic table are minerals, but just like the periodic table, you add that proton, you change the element. Well, the same thing with the chemical composition of minerals. If you add things to it, you change the mineral or it doesn't become a mineral anymore. Okay? Last but not least, they have a orderly crystalline structure. Okay? They form crystals. Now, some doesn't look like crystals that we know, like the ones that are really shiny and look really cool and, things like that. That's like quartz and stuff like that. But some of them aren't. Some of them are dull and flat and they break apart, but they're still, like if you zoomed in on them with the microscope, they would still have this cool tetrahedral in there. All right? All right. Now, this is a good table to like if you're just looking at something like if you were looking at coal. Is coal inorganic? No, it's not a mineral. Brass. Is brass inorganic? Yes. Does it occur naturally? No, brass is not a mineral. Okay, and you can keep going down the list, and that's kind of how you can find out what are minerals and what aren't minerals. Okay? Now, how they form. They form from this crystallization from magma. I said that just a few minutes ago. They can also form through precipitates. That means minerals coming out of a solution, like if they were in water or some other type of solution. You also have pressure and temperature. Now, remember, minerals may be below the surface. Okay, if they're formed by magma, that's definitely below the surface because we know that lava is considered on the surface. Okay, so if they're formed below the surface with all that pressure and rock and stuff pushing down on them, they may be flattened out. They may form different types of minerals depending on the type of pressure and temperature that they may see. Okay, and then you have hydrothermal solutions and things in water and stuff like that. Okay, here's a good example of minerals that are being leached out in a solution, like this is water, probably near a hot spring or something like that. These definitely look like hot springs, geysers, stuff in Yellowstones, and that sort of stuff. But that's how you can get minerals in a solution. Okay, all right. Okay, so let's talk about mineral groups. There are two types, okay? One, silicates, two, non-silicates. Silicates have silicone in them, okay? That's why they're called silicates, silicone and oxygen, okay? They always form these silicone-oxygen tetrahedrons. They look really, really pretty under a microscope, really, really cool, and those are silicates. And then after that, you have non-silicates, which are carbonates, oxides, sulfates, halides are on the next slide, you'll see in a second. But these carbonates, oxides, and sulfides are non-silicates. They don't contain silicone and oxygen. And these are a lot less of these than there are silicate and oxygen. Like the silicates, that's what most minerals are, silicates. Okay? All right, but there are some carbonates, oxides are cleaners and things like that. Sulfates are like fertilizers and stuff. Okay, you can get some nitrogen sulfate. That's some pretty strong fertilizer. Okay, mineral groups, halides. Halides are like that last group that needs a proton, not the noble gases on the periodic table, but that next to last group. That next to last group are those halides. They need one proton to be happy. Okay, and fluorite, stuff like that. Those are minerals. Then you have native elements, copper, gold, things like that you just occur naturally. Okay, and you just find it, mine it. All right. Okay, these are some types of sulfides here. Okay, this is fool's gold here. All right, there's native copper. All right. Oh, okay. So now we've got the 7 properties of minerals. So before we had the 5 things that define a mineral. Now we've got the 7 properties. Okay, now these are 2 very important things. We might have a little quiz on Friday, so make sure you know these things. Okay, now 7 of them. There's color, streak. All right, now luster. There's crystal form, hardness, cleavage, fracture, okay, and density. Now, cleavage and fracture here, they kind of go together, and you'll see why. Okay, now let's get into this. Color. Color's easy. What does it look like? What color is it? Is it yellow? Is it black? Is it white? Is it clear? Okay, color's easy. Streak. Streak, you need one of these little porcelain plates, these white porcelain plates, and you take the mineral and you scrape it on that plate, and it's going to give you a color. Now, sometimes you might scrape it and it won't give you anything. Okay, and that's a clear streak. Okay, but these right here, you can kind of see how those give you color. All right. Luster. Luster is how light is reflected off the surface of the mineral. Okay, so if you have something like mica, mica is very, very glassy and can reflect very easily. Okay, something with metallic, pyrite. Pyrite, fool's gold, also has a very metallic, very reflective surface. And that characteristic is what gives it its, its name or whatever it may be. Okay? All right. There it is. There's that metallic luster of pyrite, fool's gold. Now, crystal form. Crystal form is what sometimes you can see in your hand, and sometimes you have to get under a microscope and really look at that crystal form. Okay, now a lot of things can have different types of crystals, and as you can see, there are several different types of crystal forms, and depending on its crystal form, may depend on what type of mineral it is. Okay, and that's just one of its characteristics. Here's quartz. Quartz exhibits good crystal form. Okay, you can kind of see that. Okay, now I'm going to get through these silica tetrahedrons. We're not going to go over the single chain, double chain. Don't worry about all this stuff. Okay, hardness. Hardness is how hard the mineral is. That's right. Okay, we all know that most rocks are hard. Yes, we do. But here's the thing. Talc. Talc is a mineral. Talc is extremely soft. Like if you found it, you could really take it and just kind of crumple it up in your hands. Okay, talcum powder or talc powder is something that you can put on your skin to make it feel better. Okay, and there's this scale of hardness. Okay, this scale of hardness, Mohs scale of hardness, and no, it's not Mohs from The Office. Okay, but Mohs, this scientist, came up with the scale of hardness 1 to 10. Talc is number 1. What's number 10? Diamond. Diamonds are number 10. Not diamonds that you put in your ring. Don't get me wrong, those are hard too. But diamonds that you put in your ring are more valuable because they're more crystalline. Okay, diamonds that you put on a saw blade, though, can cut through almost anything. Concrete, iron, steel, you name it, it cuts through anything. It's the hardest thing on the planet. Therefore, it cuts through anything. Now, what cuts diamond? That's right, diamond. Okay? All right, so with that being said, that's how hardness works. And hardness goes on a scale of 1 to 10, and different minerals have a different hardness. Okay? Okay? Here you can kind of see it. Here's talc on number 1 and diamond at number 10. You can kind of see some of the ones in the middle, topaz, quartz. Some of those may look familiar to you. Okay, and here's a different one. You can actually see a scale like how hard things are. So like your fingernail is down here at the very, very bottom. Sorry, I'll point with my mouse. Your fingernail's down here at the very, very, very bottom. Diamonds up here at the top. But you can kind of see a streak plate, glass, knife blade, like how hard other things is. Now, a knife blade, a 5, that's freaking really hard. Okay, you know, so a diamond is really, really hard. Here you can kind of see some others. Okay. All right, so cleavage. Cleavage and fracture kind of go together because it's how a mineral breaks. So like if you take something and you break it in half, like this one right here, if you took it and you break it in half, it would have that flat surface every time, no matter what. It breaks in flat surfaces, okay? Then you have a fracture, okay? A fracture is something when you break it, it breaks and it's never going to be the same. It's going to be uneven and jagged and all kinds of stuff, okay? But that's a fracture, okay? So you have cleavage, which is a flat surface, okay? Like mica. Here's mica, breaks in a flat surface, okay? And then you have a fracture, which breaks in an uneven surface like this, okay? Last but not least is density. Density is mass over volume. Once you take the mass over volume of a mineral, then that will give you its density, and that is the last characteristic. Okay, now some special properties. You can have magnetism, you can have radioactivity, you can even have fluorescence. Okay, all right, you can get these cool things in other types of minerals. Those are a little more rare though. Okay, I hope this helps. I hope this covers minerals. I'm going to have another video attached to this assignment that's going to go, where I'm going to go over the assignment. Okay, so please watch it. Guys, please follow along. Like I said, make sure you remember those 5 things that define a mineral and the 7 characteristics. Those are very, very important, especially when doing your project. So make sure that you refer back to the video if you need to. All right, see you in the next video.